Java exceptions. An exception in Java is an event that disrupts the normal flow of a program's execution. When an exception occurs, the program generates an exception object, which contains information about the error. Types of exceptions. Checked exceptions. These must be handled or declared in the method signature. Examples: IO exception, SQL exception. Unchecked exceptions. These don't need to be explicitly handled or declared. They are subclasses of runtime exception. Examples: null pointer exception, array index out of bounds exception. Errors. These are severe problems that usually indicate a fatal error in the program. Examples: out of memory error, stack overflow error. Exception handling. Java provides a try-catch finally block to handle exceptions. Java try / code that might throw an exception. Catch exception type 1e / handle exception type 1. Catch exception type 2e / handle exception type 2. Finally, / code that always executes, regardless of whether an exception occurs. Try encloses the code that might throw an exception. Catch specifies the type of exception to catch and provides code to handle it. Finally, optional block that always executes, used for cleanup operations. Example: Java import java.utility_scanner. Public class exception example: public static void main, string args. Scanner equals new scanner, system.in. Try int number 1 equals integer.parseInt, scanner.nextLine. Int number 2 equals integer.parseInt, scanner.nextLine. Int result equals number 1 / number 2. System.out.println, result, plus result. Catch, number format exception e. System.out.println, invalid. Input. Please enter numbers. Catch, arithmetic exception e. System.out.println, division by 0 is not allowed. Finally, scanner.close. Custom exceptions. You can create your own exceptions by extending the exception class. Java class myCustomException extends exception. / throwing exceptions. Use the throw keyword to manually throw an exception. Java throw new arithmetic exception, division by 0. Best practices. Use specific exception types for different error conditions. Avoid empty catch blocks. Use finally for resource cleanup. Consider using try with resources for automatic resource management. By effectively handling exceptions, you can improve the robustness and reliability of your Java applications. In Java, regular expressions, regex, are used to search, match, and manipulate text based on specific patterns. Java provides the java.utility_regex package, which contains the classes necessary to work with regular expressions. Key classes in java.utility_regex. Pattern. A pattern object is a compiled representation of a regular expression. You create a pattern object using the compile method. Matcher. A matcher object is used to perform matching operations on a character sequence using a pattern. It provides methods for performing match operations, such as find, matches, and group. Pattern syntax exception. A pattern syntax exception is an unchecked exception that indicates a syntax error in a regular expression pattern. Basic usage. 1. Creating a pattern and matcher. Import java.utility_regex.pattern. Import java.utility_regex.matcher. Public class regex example. Public static void main, string args. / define a regex pattern. String regex equals / d plus sign, / this pattern matches one or more digits. / compile the pattern. Pattern equals pattern.compile, regex. / create a matcher to find matches in a given input string. String input equals there are 123 apples and 456 oranges. Matcher equals pattern.matcher, input. / find and display matches. While, matcher.find. System.out.println, found a match, plus matcher.group. Output. Found a match, 123. Found a match, 456. Two common methods in matcher. Boolean matches, checks if the entire input string matches the pattern. Boolean find, finds the next subsequence of the input string that matches the pattern. String group, returns the subsequence of the input string matched by the previous match operation. Int start, returns the start index of the previous match. Int end, returns the end index, exclusive, of the previous match. Int group count, returns the number of capturing groups in the pattern. Example. Import java.utility.regex.pattern. Import java.utility.regex.matcher. Public class regex example. Public static void main, string args. / define a regex pattern with groups. String regex equals, / d plus, / s, / w plus sign. / compile the pattern. Pattern equals pattern.compile, regex. / create a matcher to find matches in a given input string. String input equals 123 apples. Matcher equals pattern.matcher, input. If, matcher.matches. System.out.println, full match, plus matcher.group, 0, / entire match. System.out.println, digits, plus matcher.group, 1, / first group. System.out.println, wit space, plus matcher.group, 2, / second group. System.out.println, word, plus matcher.group, 3, / third group. Output. Full match, 123 apples. Digits, 123. Wit space. Word, apples. Regular expression syntax. Literals. A, matches the character A. ABC, matches the string ABC. Character classes. ABC, matches any of the characters A, B, or C. ABC, matches any character except A, B, or C. AZ, matches any lowercase letter. \d, matches any digit, equivalent to 0 to 9. \d, matches any non-digit. Quantifiers. Asterisk, matches 0 or more occurrences of the preceding element. Plus, matches 1 or more occurrences. Matches 0 or 1 occurrence. N, matches exactly n occurrences. N, matches n or more occurrences. NM, matches between n and m occurrences. Anchors. Caret, matches the start of a line. $, matches the end of a line. Groups and capturing. ABC capturing group, matches ABC. ABC non-capturing group, matches ABC but does not capture the match for later use. equals ABC positive look ahead, asserts that ABC follows. ABC negative look ahead, asserts that ABC does not follow. Example, email validation. Import java.utility.regex.pattern. Public class email validation. Public static void main, string args. String email equals example@example.com. String regex equals @azaz0-9 plus underscore dot dash plus @azaz0-9 dash plus $. Boolean is valid equals pattern dot matches, regex, email. System.out.println, is the email valid? Plus is valid. Output. Is the email valid? True. Advanced features. Flags. You can use flags to modify the behavior of a pattern, such as pattern.case_insensitive for case-insensitive matching. Replacing text. You can use matcher.replaceAll to replace all occurrences of a pattern in a string. Example, replacing text plus. Import java.utility.regex.pattern. Import java.utility.regex.matcher. Public class regex replace. Public static void main, string args. String input equals hello, world. Hello, Java. String regex equals hello. Pattern equals pattern.compile, regex. Matcher equals pattern.matcher, input. String replaced equals matcher.replaceAll, hi. System.out.println, replaced. Output. Hi, world. Hi, Java. Summary. Java regex is a powerful tool for text processing, allowing you to match, extract, and manipulate strings using patterns. It's widely used in tasks like input validation, text parsing, and search and replace operations. In Java, threads are the fundamental unit of execution in a program. Threads allow concurrent execution of two or more parts of a program, enabling multitasking and making efficient use of system resources. Java provides built-in support for multithreading, making it possible to write programs that perform multiple operations simultaneously. Key concepts. Thread. A thread is a lightweight process that runs within a program. Each thread has its own execution path but shares the program's resources, such as memory. Multithreading. Multithreading refers to the ability of a CPU, or a single core in a multi-core processor, to execute multiple threads concurrently, allowing multiple tasks to run in parallel. Creating threads. There are two primary ways to create and start a thread in Java. One, by extending the thread class. You can create a new thread by creating a class that extends the thread class and overriding its run method. Class MythRead extends thread. Public void run. / code to be executed in the new thread. 4. Int I equals 0, I5, I++. System.out.println, thread, plus I. Public class thread example. Public static void main, string args. MythRead thread equals new MythRead, / create an instance of the thread. Thread.start, / start the thread. / main thread code. 4. Int I equals 0, I5, I++. System.out.println, main, plus I. Output. Main, 0. Thread, 0. Main, 1. Thread, 1. Main, 2. Thread, 2. Main, 3. Thread, 3. Main, 4. Thread, 4. 2. By implementing the runnable interface. Another way to create a thread is by implementing the runnable interface and passing an instance of the class to a thread object. Class myRunnable implements runnable. Public void run. 4. Int I equals 0, I5, I++. System.out.println, thread, plus I. Public class thread example. Public static void main, string args. myRunnable equals new myRunnable, / create a runnable object. Thread equals new thread, runnable, / pass it to a new thread. Thread.start, / start the thread. / main thread code. 4. Int I equals 0, I5, I++. System.out.println, main, plus I. Output. Main, 0. Thread, 0. Main, 1. Thread, 1. Main, 2. Thread, 2. Main, 3. Thread, 3. Main, 4. Thread, 4. Thread life cycle. A Java thread can be in one of the following states. New, the thread is created but not yet started. Runnable, the thread is ready to run and waiting for CPU time. Blocked / waiting, the thread is blocked or waiting for a monitor lock or some other condition. Timed waiting, the thread is waiting for a specified period. Terminated, the thread has completed execution or was terminated. Common thread methods. Void start, starts the execution of the thread, calling the run method. Void run, contains the code that constitutes the thread's task. Static void sleep, long millis causes the thread to sleep, pause execution, for a specified time. Void join, waits for the thread to die. Void join, long millis waits for the thread to die for a specified time. Boolean is alive, tests if the thread is alive, has been started and has not yet terminated. Void interrupt, interrupts the thread. Example, using sleep and join. Class mythRead extends thread. Public void run. 4. Int I equals 0, I5, I++. System.out.println, thread, plus I. Try. Thread.sleep, 500, / sleep for 500 milliseconds. Catch, interrupted exception E. System.out.println, thread interrupted. Public class thread example. Public static void main, string args. mythRead thread equals new mythRead. Thread.start. Try. Thread.join, / wait for thread to finish. Catch, interrupted exception E. System.out.println, main thread interrupted. System.out.println, main thread finished. Output. Thread, 0. Thread, 1. Thread, 2. Thread, 3. Thread, 4. Main thread finished. Synchronization. When multiple threads access shared resources, like variables or data structures, synchronization is crucial to avoid inconsistent or unexpected results. Java provides the synchronized keyword to control access to blocks of code or methods. Example, synchronized method. Class counter. Private int count equals 0. Public synchronized void increment. Count ++. Public int get count. Return count. Class mythRead extends thread. Private counter counter. Public mythRead, counter counter. This dot counter equals counter. Public void run. For int I equals 0, I 1000, I plus plus. Counter.increment. Public class sync example. Public static void main, string args. Counter equals new counter. Mythread t1 equals new mythread, counter. Mythread t2 equals new mythread, counter. t1.start. t2.start. Try. t1.join. t2.join. Catch, interrupted exception e. System.out.println, main thread interrupted. System.out.println, final count, plus counter.getCount. Output. Final count, 2000. Summary. Creating threads. You can create threads by extending the thread class or implementing the runnable interface. Thread lifecycle. Threads move through various states like new, runnable, blocked, and terminated. Thread methods. Java provides various methods like start, sleep, and join to manage threads. Synchronization. Use synchronize to control access to shared resources, ensuring thread safety. Multithreading in Java is a powerful feature, enabling concurrent execution and improving the efficiency of